In our previous session, we have discussed corrosion control, and various methods of corrosion control. Today, let us discuss one of the major methods of corrosion control. One of the major method of corrosion control is metal finishing. What do you understand by metal finishing? I'll just give you a simple example for metal finishing or the application of metal finishing. The main application of metal finishing you can find in our kitchen. That is kitchen utensils, refrigerators, washing machines, and especially for ladies it is imitation jewelry. So before going to know what and how, where they are used, let us see what is this metal finishing. So in simple language or in simple terms, metal finishing means depositing one metal on the surface of another metal or alloy or a non-metal or a plastic. So I repeat, depositing one metal on the surface of another metal or non-metal or plastic only to improve the surface characteristics of the metal is known as metal finishing. So as the definition says, the process carried out to modify surface properties of metals, alloys, plastics, etc. by depositing another metal, polymer or forming oxide layer is called metal finishing. So let us see what are the technological importance of this metal finishing. The technological importance of the metal finishing is mainly corrosion resistance. So how does this prevent corrosion? So for instance, let us take iron, coating zinc on the surface of iron. So I've discussed in our galvanization. So galvanization is once again you are depositing zinc on the surface of iron so that you are preventing iron from further undergoing corrosion. Right, we are improving only the surface property, not the chemical properties. So metal finishing provides corrosion resistance to the metal. Decorative surface giving chromium plating to provide or improve thermal and electrical conductivity, to improve hardness, to impart optical reflectivity, to impart thermal resistance, to improve hardness, to impart wear resistance, to impart abrasion resistance. So why this metal finishing is essential? Because few metals will have good conductivity, will have very good optical reflectivity, will have very good thermal resistance, but will not have corrosion resistance. So to impart that, what are we going to do? Going to take a metal is having very good corrosion resistance and deposit on such type of metals, so that we're going to inculcate that property also in that metal. So few metals will have all this corrosion resistance will be very good. It will have, it is very good, hardness will be very good, thermal resistance will be very good, wear resistance will be very good, but the surface will be very hard. So in order to give a very optical surface, optical reflectivity, in order to give a smooth surface, you are going to deposit some other metal on the surface of that. That is the major application of metal finishing. Now let us see how this metal finishing is carried out. Metal finishing is mainly done by electroplating, electrolysis plating, or hot dipping. So what is hot dipping? So in our previous session we have discussed about galvanization. So this is, what is galvanization? Depositing zinc on the surface of iron or steel. Right. So we are going to take the base metal and dip it in molten zinc. Isn't it? So dipping any base metal in any molten material is called hot dipping. So anyhow, this hot dipping is not our part. It's not our cup of tea, right? So we have only electroplating and electrolysis plating in our syllabus. Let us discuss what is electroplating and electrolysis plating. As the name indicates, electroplating means plating using electricity. So here will have an anode, cathode. Both will be connected to a DC power supply. I'll show you in our next slide. Okay, dipped in an electrolyte. So in the electroplating, metal to be deposited is called as a base metal. So base metal means metal which takes coating or to be coated will to be coated is called as a base metal. So the metal is deposited on a base metal by passing DC through an bath solution using soluble salts of the metal. So electroplating consists of electrolytic cell which consists of an anode, a cathode and which is dipped in an electrolyte. So anode might be inert or it might be plating material itself, but cathode is always the base metal. So I repeat, cathode is always the base metal. That is, base metal means metal which takes coating or to be coated is called as base metal. Anode might be inert or coating material itself, but cathode is always the base metal. So electroplating can be done in two ways. So what are those two ways? We'll see. So electroplating, the first type is anodic consumption method. So here we'll have a electroplating unit as such. We'll have an anode, we'll have a cathode connected to a DC power supply as shown in the diagram and dipped in an plating bath solution or an electrolyte as we call it, right? So here, for example, let us consider we want to coat copper on the surface of some other metal. Okay, so the metal which takes coating is made as cathode, that is base metal. So we want to coat copper on the surface of base metal, right? So we're going to make copper as anode as shown in the diagram. So when you pass the current DC power supply, so copper undergoes oxidation giving you Cu2 plus ions and 2 electrons. So these Cu2 plus ions move towards the cathode and undergo reduction giving you copper metal which gets deposited on the surface of the cathode. Okay, so since here the metal is acting as anode is the coating material itself, and during the process of electroplating the metal is consumed. So what is anodic reaction? Cu gives you Cu2 plus and 2 electrons. So anode is dissolving, anode is being consumed, therefore it is called as anodic consumption method. Okay, so it's called as anodic consumption method. So examples for such type of plating are nickel plating, copper plating, zinc plating, etc. Okay. So next, electrolyte consumption method. So in electrolyte consumption method, anode is being made as inert, cathode as usual like previous method, it is the base metal which takes coating. So both anode and cathode are connected to the DC power supply dipped in an electrolyte which contains the salts of the coating material. Okay, so as I already told you, now anode is inert. Now I am supposed to coat copper on the surface of base metal. Previous example only. Let us take the previous example itself. So I am supposed to coat copper on the surface of the base metal or cathode. But anode is inert and does not undergo any reaction. So how to coat copper? Simple thing is, so electrolyte, as I have discussed, it contains the soluble salts of the coating material. So soluble salts usually carbonate or sulfate salts are soluble. So we're going to take the soluble salts of that particular copper and add into the electrolyte. So as soon as it goes into electrolyte, it gives cations and anions. We are not bothered about the anions. Our worry is only about the cations, that is Cu2 plus. When you pass current, so already Cu2 plus ions are present in the electrolyte. When you pass current, what happens? Cu2 plus will move from anode towards cathode and undergo reduction. So when it's undergoing reduction, that is Cu2 plus electrons will accept electrons and will get deposited on the surface of the cathode. It will get deposited. CO2 plus ions which undergoes reduction will be deposited in the surface of the cathode. So since in the electrolyte CO2 plus ion concentration is reducing, it is called as electrolyte consumption method. So example for this electrolyte consumption method is a chromium plating, nickel plating, etc. So we'll discuss this chromium plating later in our sessions. Electroplating is mainly governed by three principles. Those are polarization, decomposition potential, and over voltage. So what are this? What is polarization? What is decomposition potential? What is over voltage? We'll discuss this in our next sessions. Thank you.